how to use HSRP to provide redundancy in a multi-homed BGP network. And it says updated here because I have done this video, I mean this lab in the past. I want to do it again just a refresher. So I have this topology. This is the same topology, almost the same topology that they have here in this document. So I kind of just make it uh, this way. So AS, let's just assume that AS 100 is the customer AS, and AS 300 and AS 400 are ISPs, and of course AS 600 could be another ISP. So let me just go to this note. So I have created um, a list of tasks that we can actually perform while verifying things and simulating a failure on R1 a little later. But before that, let me just show you the BGP, the topology or network diagram here. So same, like I said, what they have here in this document. And yeah, so let me just make it a little bit bigger. Yeah, so like I said, R1 and R2 are in AS100. ISP 1 is in AS300. ISP 2 is in AS400, and R6 is in AS600, and it has a loopback interface configured. This interface here, not an interface, this IP address configured on its loopback 0 interface. And of course here we have HSRP configured on both R1 and R2, and currently R1 should be the active router. And there's also IBGP peering between R1 and R2, and EBGP peering with R1 and ISP1, and another EBGP peering with between R2 and ISP2. And you can see it here, IBGP peerings between these routers. Okay, so let me talk a little about the configurations. So in the document, we can only see the configurations on R1 and R2, but we don't see the configurations on ISP-A, ISP-B, and R6. So I just, kind of just created basic or configured basic configurations or basic BGP configurations on the rest of the routers that don't have configurations in the document. All right, so let's look at R1. So R1 is, like I said, is the active HSRP router, and we can see that uh, it has a priority of 105, so that's the reason why it's the active router. And R2 only has the default priority, which is 100, so we don't see it here in the configuration. And R1 is actually has a track configured. So it's actually track 101, and when that track goes down, the priority will decrement to 10. I think this is also by default 10. And you can see that here we have IPSLA configuration. So let me just explain this a little bit. ISP, I mean IPSLA is basic. ISP SLA1 is basically pinging this IP address, which is ISP1. This IP address here, .3, and it's pinging it every 5 seconds. Yeah, I believe 5 seconds. So it's gonna run for forever. And another ISP SLA2 is just pinging this IP address, the IP address on the loopback interface on R1. So same, it's pinging it every 5 seconds, frequency 5 seconds, and it's going to be running forever. And we have created track one and just calling the IP, calling IPSLA1, and basically saying that we're gonna track its reachability. And also same with track number two. And here track 101 list Boolean is this is basically objects one and two are basically the track objects. So here. So I'm going to simulate a failover test later. And what else should we talk about here? Yeah, so that's it. I mean, BGP configuration looks um, I mean, it's got a basic, almost basic BGP configurations, except this one. This is something that you don't see, at least from my experience. So this is basically saying that because it's got a IBGP peering with, let me check, R2. So you know, next hop attribute is not exchanged between routers in IBGP peerings. So yeah, so that's why we are configuring it. And same with R2 actually. Oops, here. Yeah, as that's at least what I know. Okay, so coming to R2 configurations. So we have configured a AS prepending here. So basically this is I mean, we are matching this network, which is /24. Yeah, /24. And we are creating a route map um, and matching that access list here and set a AS path prepending. So we are using the local AS 100 and apply that route map outbound to neighbor R4. Yeah, here, outbound, because we are trying to um, make this link here, I mean, to have this link a longer AS path. So, so we want to, um, for example, R6 wants to get to this route. We need to use this. We need R6 to use this link, the link between R1 and R and ISP1, not this, not the link between R2 and R and ISP2. And we can verify that later. Okay, so I just also added the configurations for the rest of the routers. As you can see it here, ISP1, ISP2, and R6. Okay, let me go and perform these tasks. Okay, check BGP peers and prefixes on all the routers. Okay, can do that. So I can just say, okay, it's got a IBGP peering with R2 and EBGP peering with R3, I mean ISP1. Yeah, and prefixes. Um, so it's learning a default route from ISP1, also this route from ISP1, and so of course this, hold on. Yeah, here it's advertising this route into BGP, and the next step is itself because it's originating that route. So that's expected. Let me go to R2. So same here actually. I'm going to discuss that in more detail. So here, let me show you the topology. So here, I mean, R2 is learning a route, I mean, a default route as well from ISP2, which is expected, and this route from ISP2, which is expected, and it's advertising this route or originating this route. That's why it's selecting this next hop itself as the selecting itself as the next stop. So that's expected. Okay, let me go to ISP1. So it's got a EBGP peering with R1 and R6. And let me just check the BGP routes. I mean table. Originating the default route. Okay, that's fine. Let me check ISP2. Yeah, it has a IBGP peering with R2, which is expected, and EBGP peering with, did I see I? Should be E. EBGP peering with R6, so that's expected as well. Let's check the BGP table, okay. Learning this, okay, yeah, originating this default route and learning this route from R6. So next hop R6. Let's check R6. It's got a ABGP peering with R ISP1 and ISP2. Yeah, checking the BGP table. Okay, it's learning this route from ISP1. So we're gonna do that now. We're gonna perform this. I mean, the next is, yeah, we're gonna also verify this one. This one. So next is show into standby brief on R1 and R2 and check which one is active in standby. Okay, so from R1, I'm going to standby. Going to do a standby brief. So it's the active router, and R2 is the standby router. Okay, that's done. And check inbound and outbound traffic. So we did. Okay, let me just check that as well. We checked this earlier. Yeah. So to get to this route and this route, the next step is ISP1. So expected. And to get to the default route, next step is ISP2. To get to this route, next step is ISP2. So that's expected. So trace to, okay, I'm going to trace to that route, which is, this is the IP address on that loop back on R6. Hold on. That's not right. Show IP. That's got an IP address. Didn't save it. That's fine. I'm not going to configure an IP address on PC1. I'm going to use PC2. It's fine because both are in the same subnet. So I'm going to use ISP2. I mean PC2. Okay, so now we are using this link here. So gateway, this is our gateway, which is R1. I mean next up, not gateway, because gateway is .10. Next up, this, which is R1 and R3, ISP1 and R6. So okay, that's fine. So we are choosing this link here. And next is traceroute to, okay, so the opposite direction. Oops. Let me just. So from R6, I'm going to ping, not ping, trace. Is that again? This IP. So 200, 192.168.21.200. Okay, so from R6, we are choosing the same link. So this link on the left. Okay, so that's expected. And okay, so this part is done. So now we can simulate uh, uh, simulate to fail over the traffic from R1 to and fail over it to R2. So we're gonna shut down this link and see if the link will traverse through R2 and ISP2 link. Okay, so I'm going to shut down R1. I mean that interface on R1. So that is shut down. Yeah, shut down. Okay. So we see the logs. So let's check. Show standby brief. Give it a minute because, yeah. So down. Okay, so we see that the track objects went down. So ISP1 and ISP2, I mean ISP, IPSLA1 and ISPSLA2 went down, both went down, and we see that this track list Boolean or up went down as well. So we should, okay, now we see that ISP2 is the active router, so that's expected. Okay, so from ISP2 we can check uh, the BGP table and see what is the next step now. Or actually, let me check from the BGP table in R1. Okay, so on R1, to get to this route, we need to use ISP2. I mean R2. So that's the next step here. And to get to this route, next step is this. Which this is expected. And on R2, to get to it will have the same next step, which is our ISP2, because that's the link that it's using. And next is, okay, I'm going to traceroute from, do that traceroute again. Of course, it's gonna choose this link because this one is down. Hopefully, but it looks like it's not working. Oh, that's weird. Let's check from R6. I think it hasn't converged yet. Hold on, that's weird. Okay, ISP2. Okay, ISP6. Okay, yeah, it got there here. It's just that it's got timeouts here. Let me do it again. Yeah, now it's better. And this one, yeah. So I think it's just my laptop that it's causing these drops. So my laptop is not very powerful, but now it's working. So we are using this link here on the right to get to both ends. So to this, from this PC to here, and vice versa. So that works. So I'm going to unshut that interface on R1 and see if all the original settings or setup will come back. Okay, save it. Let's wait for the logs. Okay, this is, what is that? That's three, yeah, that's ISP1. Okay, so it changed from standby to active, so it's now, R1 is now the active router. And the reason it's doing that because we have preempt configured on both routers, on R2 and R1. There's a delay, minimum of, I think this is 60 seconds. Okay, so let me check now. Check brief. Yeah, so this is expected, the active router, brief. Okay, I'm going to perform that route, I mean trace again. So now it's choosing the original path, which is this link here on the left. And from R6, it should use the same link. Yeah, it's choosing this link here. So yeah, that's how you can use HSRP to provide uh, a redundancy in a multi-homed BGP network. So yeah, that's all I have in this video. Thanks for watching, and I'll see you on the next one.